Okay guys, so let's continue the first question on the balancing system, the single balancing rotation mass. Just guys, please focus because you need to focus because the first question actually will build you the background and the base for the whole chapter. Just focus. If you actually focus this question, all the question to be very easy because we will add some more details, some more formula. Just focus on this part of the question. First of all, when I face the balancing question, what I supposed to do? The first steps, if I faced the balancing problem in the exam, I supposed to check what is my case. The case is single or double. So if I want to check for the type single or double, I directly go for the mass that is in x and y plane. And x and y plane masses, I check it is aligned in the same line, it's aligned vertical in the same line, or aligned horizontal. So as in this question, I noticed that it is aligned in the vertical line. If it was the vertical line, guys, you're supposed to review the part 1. If it was aligned in the vertical line, so directly I go for the single. So this type is single balancing rotation mass. So the first steps, I check for the type, because if I actually analyze it in the wrong way, I will lose all the mark in this question. So the first thing, I check for the type. The second thing, I supposed to adjust my angle, because these angles, not the original angle. I supposed to find out the original angle for the balancing rotation mass. So first of all, I check. After that, I find out the specific angle. If we go in this table, actually this table, all to be given in the question, the mass will be given, the radius will be given, that's all. Will be given the mass and the radius. If it was single, I just applied mass, radius, x-axis, y-axis, that's all for the single. So first of all, the masses will be given, the radius will be given. I'm supposed to find out the rest. Okay, great. I check for single, I check for the type, so I switch for the table. First of all, given. When I go for the x-axis, okay, when I go for the x-axis, so the formula for the x-axis and the y-axis is, the formula is for the x-axis is the mass times the radius times cosine the angle. The y-axis, the formula, the mass times radius times sine the angle. Okay, first of all, the first column, I have for the x-axis, I don't have 0. For x-axis 0, y 0, when we, so guys, just please focus. This table actually for the second plane for the xy. The first plane for the xy without any angles, I just check for the type. Here I check for the type. I have two plans. The first plan without any angles, I check just for what? I just check for the type, single or double. After I check, I clarify what type, I skip it. My workout would be in the second plane for the balancing rotation mass. With the angle, I suppose just focus on it. I suppose just focus on it. Great. So, ouch. The table just for the second plan with the angle. First, just for the type. So, great. So, first of all, y in the x-axis 0, y 0, I go in the second plan. Okay, the second plan. I see what the n1 for the mass one, they just align in the y-axis. There's nothing work for the x-axis. So that's why and the x-axis is 0, because where's the m1 and the y just, and the x 0. Great. And the y-axis, the m1, I have no given, radius is given, m given, radius given, sine theta. Why there's no angle? Because as it's shown, the m1 actually is aligned vertical without any inclining, so I don't need for the angle. Great. So 2 times the m times the r. Okay, and you got the answer on the calculator. So we shift for the second mass, the m2. The m2 is given by 1/2. The radius to 35. I switch for the m2. The m2 actually have the angle 15. Great. Where is the m2? In which coordinate system you're supposed to review the part 1? The coordinate system for the m2 is where is on the minus x and the minus y. On the minus, so it is in the third coordinate system. It is possible to be 15 in the third coordinate system? Definitely not. It cannot be, not logical to be 15 degree in the third coordinate system, because the third coordinate system from 180 to 270. So I suppose to find out the original angle specified in this coordinate system, the third coordinate system. So the angle is, so first of all I have on the x-axis, I have on the x-axis, I have on the y-axis, because it is inclined. Okay, in the x-axis I have 1/2 the m2, 35 the radius to cosine 195. Why 195? Because it is, you're supposed to review the part 1 video balancing. If it was in the third coordinate system, the angle, not logical angle, 15, I'm supposed to what? 15 times 180, because it was in the third coordinate, I got 195. So I apply, so okay, 1.5, 35 cosine 195, and you get the answer. So the same as for the y-axis, just I change the cosine into sine. Great. So switching for the third mass, I have mass given 3 kilogram. I have 40 the radius. How about the angle? I have m3. It is where is located on the fourth coordinate system. So you're supposed to review the part 1 video. If it was the fourth coordinate system, not logical angle 75, because it's supposed to be from 270 to 360. So I cannot work with 75 degree. I'm supposed to convert it, but 360 minus 75, and I will get the correct and the original angle. So you're supposed to review the part 1, variance is 3 for the angle. Actually I will get 285. So easy peasy, just steps. شباب easy peasy. شنو؟ الماس راديوس. راح يعطونا كافي، قلت لك أول شيء تسوي الطريقة الأولى، أول بلان تشيك على الماسات. إذا شيكت سنجل أو دبل خلاص جينا. بعدين you shift to the second plan. روح حق الثاني، تشيك الماس. أول ماس صاير بس بالواي، ما في زوايا، ما في كمان خله. ثاني ماسات كمل عليهم، ما في أي شيء. Very clear. Just focus on it. Okay. When you have all the results on the table, so you add all the x-axis and you add all the y-axis. Great. So first of all, when you add the x-axis, you will get something called rx, and if you add all the y-axis, something called ry. So you get the rx and you get the ry. After adding all the x-axis, you will get the rx. After adding all the y-axis, you will get ry. Okay, great. Let's continue. So, what is required in the question? What's the requirement? So, the requirement is you need the resultant for the mass balancing. So, the resultant equal what? The Rx, come on, Rx square plus Ry square and square root. Okay, I will got this answer, that the unit. Okay, so I got the first resultant answer. After that, actually you want the angle orientation. Just focus for the angular orientation. Okay, the angular orientation, just focus on it, the angle orientation. So I have one formula, MC times RC equal the resultant. The MC, I need the MC because it is not given in the question. It is given in the question that the RC equal 15 millimeter, and actually the question actually it will be shown in the video, in the first second of the video. You're supposed to stop it and capture the question. Any rate is given in the question, in the letters of the question, not on the description down, in the letters of the question. Okay, it will be the radius. It will be any radius in the question that is not specified. That's R1 or R2 or R3. It will be the RC. Okay, you got it? You got it or not? Great. So I have the formula MC times RC equal the result. Great. I don't have the MC. Always I don't have the MC. All the question, you're supposed to find the MC because always the RC is given. Okay, that's easy peasy. I get MC, I get 1.63 kilogram. Okay, now I want to find out what. So now I want to find out the angle C, the angle orientation. So first of all, I got the resultant. After that, I got the MC because he will ask for the mass. The MC, the mass for the balancing. Okay, the mass after balancing, I got the mass. Okay, and he asked for the angular orientation. So how I can find the angular orientation? Easy peasy. Tan. Okay, shift tan minus Ry over Rx. Great, and I got this angle. Okay, guys, just focus. Memorize it. For the angle orientation, it's a bit different a little bit, because if you get the angle orientation, okay, you're supposed to check which coordinate is the angle. Please guys, just distinguish between the angle orientation and the angle that's specified in the question. Okay, there's a difference. If the angle is specified in the question, I explained in the beginning how to find the original angle that's in the beginning of the question. I explained how to find out the angle, but in the angle of orientation, if you got the angle for the angle orientation, it's actually different between the angle and the question. You're supposed to have difference between of them. You're supposed to find out the difference. It is not the same. Okay, for the angle orientation, please focus. If you find out the angle orientation, after that you check the coordinate. The coordinate as it's shown, the Rx minus 19.65 and the Ry is minus 79. Okay, minus, so it is the third coordinate system. If it was the third coordinate system, you'll plug the same angle. Memorize it. It will be the same angle. You will not change the angle. You will not change the angle the same. If you found out that the angle orientation was in the first coordinate, you're supposed to add 180 with the angle that you got it from this formula. After that, you got the original angular orientation. Okay, if it was the second, if you apply this formula for the angular orientation and it was the second coordinate, you're supposed to 360 minus the angle that you found it, and after that you found out the original angle angle orientation. As like as before, for the fourth 180 minus the angle that you find it, and you find the original angle orientation. So guys, to summarize, the first question, the single question part. First of all, what you're supposed to do? First of all, in the first plan, you're supposed to check double or single. After that, skip it. You go for the second plan with the angle. You have the table. You have if it was the single x-axis and the y-axis at all. Be given the rates and the mass. You're supposed to check where is it, the M1 line, the y-axis, great, and you follow all these steps. He need the resultant, easy peasy. You want the mass for the after balancing. You got the mass, the total mass after balancing. You got it, okay. You want the angle orientation. The angle orientation is different from the given angle, because the given angle in the table is different than the angle orientation. You're supposed to focus on this part. Don't mix between these two angles. You're supposed to review, as I explained in the part 1 balancing. I'm talking about the given angle. I'm not talking about the orientation angle in the first video part. I'm talking this angle in the table, not about the angle orientation. Now, about the angle of orientation, great. After you got the angle, you're supposed to check the Rx and Ry. Which coordinate system? Based on the coordinate system, you add a 180, you minus 360, you keep it the same, you minus 180 from that you found the angle orientation to get the original angle orientation. I hope this video was very clear about the single translating rotation mass. See you for the double next video.